College Algebra, Lesson 1, Section 6, Other Types of Equations and Applications. We have rational equations, that means problems with fractions. Work rate problems, I'd be like, Sally can mow the yard in 5 hours and Sam can mow it in 2 hours. How long would it take them together? Equations with radicals, that'll be ones that have square roots in them. And then equations in quadratic n form, and that's going to be our u substitutions. So this first rational equation, I have 5 over 3x plus 1 equals 7/6. The first thing you're going to want to look at on all of these is what is your least common denominator. See, this least common denominator would be 6x. So if my least common denominator is 6x, I now know also that x can never ever equal 0 for this problem. Because see, if x equals 0, that would give me a 0 on this denominator, which would be an undefined number. So please remember that you can never in your life divide by 0, so therefore always look for those restrictions. Because if I get x equals 0 as an answer, I must throw that answer out. Now I'm going to multiply every single one of these fractions by that least common denominator. So I'm going to take 6x times the first fraction, 6x times the second, 6x times the third one. Now in doing so, this 3x divides into 6x 2 times. So that's going to give me 2 times 5. This will just say 6x times 1. In this situation, the 6's divide, they reduce, and that would give me 7x. Now, personally, I would have went from here to here. Here's what I would do. I would say, well, 3x needs what? What does this need to turn into a 6x? So this needs to be multiplied by 2. So 5 times 2, there's my 10. This is 1 over 1. To make that denominator a 6x, this one needs a 6x. So times 6x times 1. This one just needs to be times by x. So times by x, that gives me my 7x. And now I just solved my problem. So subtract the 6x over, which would give me 1x here equals 10. Now this one's actually fairly easy to check. I could plug 10 into this. So if I check it, that right there is 30. 5 over 30 would reduce to 1 over 6. 1, 6 plus 1 happens to be 7/6, so this just check. All right, this one's a little bit harder. The first denominator is a monomial of 2x. Second one is a binomial x plus 1. That third one factors. Hopefully you see that you could take out a 3x out of that. You factor out a 3x. Now, when I look for that least common denominator, first I'm looking at the monomial parts. That's a 3x, that's a 2x. So that part of the least common denominator is 6x. And then these have an x plus 1. So that least common denominator is 6x and x plus 1. Now again, please always look at those restrictions first. So again, this x right here cannot be 0, and this x right here cannot be -1. It's very important to look for those restrictions. So sometimes you have to throw out one of the answers because it ends up being a restriction. Alrighty, so now in terms of what do the denominators need? I like to ask in terms of what do they need. The notes here are showing that we multiply both sides by that 6x and x plus 1. So I'm going to kind of, so in other words, like what would this denominator need to turn it into that right there? See, this would need to be multiplied by a 3 to turn it into 6x, and it also needs to be multiplied by an x plus 1. The way that they're doing it, notice here the 2x goes into the 3 times the x plus 1 I just said, then times 1. All right, let's come back to this one. This had an x plus 1. It already has that part, so it needs a 6x. I would times that 1 by 6x. See, right there, minus 6x. This denominator already has a 3x and an x plus 1. So the x plus 1 we already have, so I don't need to worry about that. I already have this x, but I need the 3 to turn into a 6. So I would times this by 2 and times that by 2. That's where this comes from. So again, this is a little bit messier to me, I'm thinking. I prefer just to go from here to here. What does the denominator need for you to make them all the same? So again, that one was times by 3 and x plus 1. So I took the top times that. That one times 6, x. And then this one just times by 2. Now I distribute this 3, so 3x plus 1. 3x minus 6x is a negative 3x right there, combined. So minus the 3 over and divide by -3. And again, check against the restrictions. X is 1/3 is good because it couldn't be 0 or -1. All right, solving again. We want to factor. That first one factors to x plus 5 and x plus 2. The next one had a greatest common factor of 3 to take out, an x plus 2, and that one is an x plus 5. The other thing I would advise you to do on this, I would advise you not to make this a minus. I advise you make this a plus and make that right there a -1. Make that a plus and a -1. All right, so the least common denominator is going to be x plus 5, x plus 2, and 3. Already have that, already have said that. All right, your restrictions from the first one, x cannot be -2 right there, and x cannot be -5. If I get those for solutions, throw those out. All right, so now I'm going to look at what does the denominators need. See, this first fraction is missing what? Again, you're looking back right here. Hopefully your thing is missing the 3. So I need 3 times x plus 2. So again, I'm going to click a couple steps here because I want to go to this step. So this needed the 3. So 3 times the quantity of x plus 2. All right, second fraction. It already has the 3, already has the x plus 2. It needs the x plus 5. So I take 1 times the x plus 5. Third fraction. It's missing the 3, so it needs a 3, and it needs an x plus 2. So this is going to be -1 times 3 times x plus 2. Well, -1 times 3 is -3. Then there's my x plus 2. Now we have an Algebra 1 looking type of problem. So we distribute, combine like terms. 1x minus 3x, -2x. 5 minus 6 is -1. Add 2x to your left, so that's going to be a 5x. Subtract 6 to my right, -7. Now divide by the coefficient of x. I want the x by itself, so I divide by 5. We get an answer of x equals -7/5. Again, check with the restrictions. X cannot be -2 or -5, so we're good with that. Should be good. Now you could plug them in to check these. These are pretty difficult to check just because you get these fractions within all these fractions. So it is pretty tough to do a plugging in checking. Alrighty, this one here, 1 over x minus 1 equals 2 over x plus 1. They're both factored. Common denominator, x minus 1 times x plus 1. The things that x cannot be 1, x cannot be -1. So those are your restrictions. The easiest way to do this one, because it is a single fraction on the left and a single fraction on the right, would be to cross multiply. In other words, take 1 times x plus 1 over here. Take 2 times x minus 1 over to this side. Distribute. Subtract x, add 2. So x is 3. Check it against the restrictions. Again, x couldn't be 1 or -1. We had x is 3, so the answer is good. All right, a factor again. So the first denominator is actually 3 minus a and 3 plus a difference of squares. That least common denominator will be 3 minus a and 3 plus a. Restrictions, a cannot equal what numbers? Hopefully you're thinking a cannot equal 3, a cannot be -3, because that would give me zeros in the denominators. So what does the first fraction need? Nothing, just leave it at 12. Second fraction needs 3 minus a. So I'm going to do 3 times 3 minus a. This already has a 3 minus a, so this one needs a 3 plus a to be 2 times 3 plus a. So let's jump down to there. So again, 12 didn't need anything. This 3 times what was missing, 3 minus a. 2 times what's missing, 3 plus a. Distribute both cases. 12 plus 9 is 21. If I add 3a over here, that's 5a. Subtract 6 to the left, that's 15. Divide by 5, we get a is 3. But look at the restriction. See, we said a could not equal 3. See right here, if I plug 3 into there, 9 minus 3 squared, 9 minus 9 is 0 on the bottom. I can't have that. 3 minus 3 here would be 0 on the bottom. Can't have that. It's an undefined. So make sure these rational equations, these are the ones with the fractions, that you plug your answers in, that you don't get a 0 in the denominator. So this one had no solution because a equaled 3, but a could not be 3. No solution. So Lisa and Keith are raking the leaves in their backyard. Working alone, Lisa can rake the leaves in 5 hours, while Keith can rake them in 4. How long would it take them to rake them together? So you realize if she takes 5 hours to do the job, then she can rake 1/5 of the job, 1/5 of the yard per hour. See, if it takes her 5 hours total, then what fraction of the yard does she do in 1 hour? So she does 1/5 of it per hour. Keith does it in 4 hours, so his rate would be 1/4 of the job per hour. Now, if I add the rates together, that should equal the rate together. So, again, I'm going to do 1/5 plus 1/4 equals 1 over t, where t is the time together to do this job. Now my common denominator would be 20t. So that means this one's missing the 4t times 1. That one's missing the 5t times 1. That's missing the 20 times 1 is 20. So that's 9t. 20 divided by 9, that's how many hours it takes them working together to rake the leaves for this yard. I'm going to pause the notes at this point, and then we'll continue 1.6 in just a second.